In this video, we'll discuss the crucial concept of the critical region. Basically, the critical region is the range of values for a sample statistic that results in rejection of the null hypothesis. So basically, the approach to hypothesis testing we usually use is, we set a small probability alpha, usually 0.05, of making a type 1 error, and then choose a critical region that will minimize the probability of making a type 2 error. Okay, so let's look at two examples of what the critical region might look like. So remember example 1 about the cell phone defective chips. The null hypothesis was there's less or equal to 1% defective. The alternative is they're more than 1% defective. So when would you want to reject the null hypothesis? What would be sensible? If p hat, the fraction of defectives, is greater than or equal to some number. And that would give you a type 1 error of 0.05 if you pick the cutoff point to be a certain number. And then basically, that would give you the smallest chance of a type 2 error because you're rejecting in a sensible way only if the sample fraction of defectives is greater than or equal to that critical value. You wouldn't want to reject the null hypothesis if you had very few defectives. Now let's look at example 2, where we're trying to see if a congressional district has a lower income than the country as a whole. Well, when would you want to reject the null hypothesis? You'd take a sample, and if the sample mean was too low, you would reject the null hypothesis. Now the question is how low? It depends on the level of proof you want, and if you want a 5% level of proof, which is the usual, you have a formula you can plug in that gives you the cutoff point on the sample mean that results in rejection of the null hypothesis. Now in our next video, we'll actually start doing hypothesis testing, and we'll start with probably the most basic hypothesis test, the one sample z test.